Hello, everybody, and welcome. I am Craig Martin. I am Senior Release Manager at SAS. I'm hosting this session. And a few things before we get started. We are deep into day 2 of TISCA. Hope everybody's enjoying it and enjoying the information that's been presented so far. A couple of things. We are going to have chat and Q&A going throughout the session. Feel free to chat all you want. We do ask that if you have questions, put them into the Q&A section. There is a cool little button there to upvote. So if you see a question, this happens to me all the time, that someone asked the same question I was getting ready to ask, just click on that upvote and it will raise it to the top so that it makes sure we get that one answered. With that, I'd like to introduce to you Gregory. Gregory is a solution architect at Parasoft, providing consulting services for Parasoft's testing solutions to prospects, customers, and partners. He has spoken at conferences on the topic of service virtualization and the deployment of disposable environments in the cloud. With that, Gregory, it's all yours.
Awesome. Thank you very much, Greg. Pleasure to be here. We can probably go ahead and skip the introductions here, but feel free to reach out, feel free to connect. We've done a few of these talks, and if you're looking for any additional information or have any follow-up questions, please feel free to reach out. That being said, let's actually go ahead and get started on today's topic, which is wrangling, Corral and Wrangle, quality problems, availability problems, etc., with API simulation and service virtualization. And in today's presentation, I'd like to start with an analogy, and I try to think of a sort of a Western theme analogy that's better than this, but I really couldn't. But testing APIs, testing services, testing application systems, exposing endpoints, APIs is a lot like a faucet. If you've shopped for homes in this last year, or if you've purchased a home, or even looked at any homes or apartments, etc., you've probably walked around a little bit. You've probably turned on the faucets just to see, is the water flowing? Is there cold water? Is there hot water? Right? Maybe take a look at the water, make sure it's clear, fill up a glass, bring it up to a light, see if there's anything floating in there. And in that way, you're just kind of validating that the plumbing in this house, the plumbing in this condo or apartment, in this unit, it works, right? There's a water heater, there's pipes, etc. Pressure regulators and things like that all work to deliver water out of a faucet. And testing APIs is a lot like that. Testing endpoints, testing applications is a lot like that, where you might be hitting an endpoint with some JSON payload, you might be getting some JSON response, and you're validating on some elements in that response. But what you're actually validating is all this other backend orchestration, right? All these other operations that are taking place. And testing APIs on their own, if you're just getting that response, that's easy enough. But testing it as a part of a complete structure, as a part of a complete plumbing system, that can present a challenge, because every time you want to validate your API, every time you want to validate a particular component in your application, you have to make sure that all this plumbing exists. You have your water heaters, you have your pressure regulators, etc., so on and so forth. And that's where we really start to look at things like service virtualization, is because from a testing perspective, from a test environment perspective, or from a dev portal perspective, or a sandbox perspective, getting all of that infrastructure up and running quickly can be a challenge. And so service virtualization can really help with that. We'll kind of take a look at some of the analogies here in terms of how various components map to different types of service virtualization. But as a general concept, that's essentially what we're doing. We're looking for ways to validate a subset of functionality of a system, and we're looking for easy, deployable, cheap ways to stand up all of that infrastructure, to stand up all of that plumbing in order to do so. So from a testing perspective, from a environment perspective, what really makes our test environments or stage environments, what makes these systems so brittle, right? Well, it's the fact that when we test one endpoint, when we want to stand up one endpoint, we're not just standing up that one endpoint, right? We're not just deploying one service in a container somewhere. We're typically standing up all of these other services, databases, maybe mainframe connections, and things like that, in order for this complete orchestration of events to take place, in order for us to get a response. And those components may not be available for a variety of reasons, right? So availability is a big constraint here, because you know it could be just as simple as some service being developed on a different cadence, on a different schedule, not currently available. Maybe some functionality, some subset of that service, some functionality is not available for complete end-to-end testing or for developing against that endpoint. So there's behavioral constraints within the system under test. It could also be cost. If you're integrating with third-party systems, obviously, they might charge you for using their sandboxes. And if you want to do something like performance testing, those costs will climb exponentially, right? If you start getting to 10,000 hits per second, or something beyond that, those third-party systems are going to bring a lot of cost to your test practice. And of course, data. So data is a common um, a common constraint for either testing or developing or onboarding. um, Having access to records that haven't been burnt is a lot like playing Jenga, right? Especially if it's a shared environment. If you're testing in a shared environment and you have limited amount of data to test with, even if you clean up after yourself, right? Even if you maybe delete a record that you've created, or try to bring that record to its initial state, you're kind of putting that piece back on top of the tower. So a clean testing environment, or a clean test automation environment, should have uh, test data in its initial state, right? You always want to be able to start with a clean slate, and that actually brings us to sandboxes. So what makes a test sandbox a good sandbox, right? What makes it valid? What makes it um, useful in terms of testing against it, or even developing against it, or onboarding customers or new employees into your organization, and helping them familiarize themselves with with your application, and how that technology works. Well, let's define a sandbox first, right? So, sandbox is a testing environment that isolates untested changes and outright experimentation from the production environment. Basically, we don't want to push untested changes. We don't want to push untested implementations directly into productions. We want to validate those things somewhere first, and those are lower stage environments, essentially, that we're referring to, and these are the environments we're trying to capture in a sandbox. So a sandbox, just like a production environment, should be well built, right? It should undergo all the same testing that the real services would, that your production environment would. So it has to be able to do the things that the real systems do. It has to be well documented, right? There's always changes from sprint to sprint, whether your service changes, your service definition changes, there's new resources being added, schema changes, etc. Those things should all be up to date. Those things should be maintained in a sort of a programmatic kind of way, where um, you know when you deploy a sandbox, it should be up to date, and any recent changes should be well documented between those versions. It should be readily available, right? So nobody likes to wait to gain access to their environments, whether it's a test environment, whether it's a dev sandbox, whether you're onboarding customers. Uh, these sandboxes, they should be available on demand. Um, for test automation, right? You want to get quick feedback. You want to get fast feedback from your DevOps pipelines, from your continuous testing implementations. So when you do run your test automations, you should be able to spin up those sandboxes, test environments dynamically and quickly, and get feedback. And of course, they should be secure, right? So you don't want to have overlap between various teams. You don't. Uh, Data shouldn't be spilling, from one sandbox or one test environment to someone else's test environment. We don't want that Jenga situation, right, where people are pulling, pieces all out of order and kind of just putting them back. Everyone kind of should have their own um, initial Jenga tower that they can work with, that they can that they can test against. So with that, we bring in service virtualization. Service virtualization really does check all the boxes here in terms of enabling this type of test automation or development, right? So service virtualization, and we'll see how we can do all this, does enable teams to provision and validate complex environments on demand. So whether you're doing it programmatically through your Jenkins pipelines or Puppet or something else, right? You can stand up these environments quickly, and you can configure your applications to talk to virtual components, real components, some hybrid model of that, without having to constantly redeploy your application over and over and over again. It should have a lot of functionality, frankly. Systems are complex. Services, even microservices can be very, very, very complex in their logic. So your sandboxes should reflect that complexity and should be able to reflect that complexity. A big topic here is obviously stateful transactions, right? So if you have a user flow or a test flow where you're modifying a specific record, those changes should persist in that environment, right? You may have other tests that depend on those state changes, and that all of that has to be valid. Easy, secure, flexible deployment architecture has to be scalable, right? Whether you're scaling it out with Docker containers or OpenShift or something else that your organization uses for deploying infrastructure, all of that has to be supported and has to be supported in a sort of intelligent way where it doesn't add additional costs or additional overhead to your team or to your organization. And finally, administrate and control deployed sandbox environment. So what happens beyond that, right? Once you have all these sandboxes, once you have all these test environments, we have teams that are leveraging this. How do you quantify this? How do you extract value from this practice? And how do you enable other teams to reuse what you already have um, to aid in their test and in their automation practices? So let's start with the first one. How to provision and validate complex environments on demand. For this, we'll actually use a demo application here, um, and I have um, an application that we can use. So let me go ahead and share my screen here. We'll start with a demo application. It's called Parabank. Just a simple, banking application. If you work for a financial services company, your application may look something probably a little bit more complex than this, but uh, nevertheless, this Parabank application does have some basic functionality where users can log in, do simple things like transfer funds, open new accounts. Right, I have some accounts with balances in them, and if I'm testing this application and I have a Jira requirement or some work item to validate some functionality within Parabank, that might be validating this request loan operation, right? This request loan operation where I can simply request some loan, let's say $1,000 loan with $150 down payment. We can go ahead and apply for this loan, and at this point, in the context of validating this application, I'm looking for either a positive or a negative response where I'm either approved for a loan or I'm denied a loan. However, what I'm actually getting here is an error from the system. I don't really know what this error means. I don't really have too much insight into my application under test here, unfortunately. But in any case, I'm stuck, right? And at this point, this is probably the availability component where some endpoint, some resource, some service somewhere is not available for me, and therefore I'm not able to do my testing. Uh, and this is where we need to be able to provision our environments on demand without actually having to redeploy the application. So having solutions, having tools where you can actually understand the health of your system, understand the health of your application under test, uh, becomes crucial, right? So, for example, here, what I'm looking at is its environment manager. This environment manager is telling me that, hey, in your Parabank system, you have components here. It looks like this retail component is healthy and it's up and it's live. The database looks good as well. However, the loan processor is actually currently offline. And there's even a health check here. There's even a test that will tell me that looks like it's returning a 404, right? This loan processor is actually returning a 404. So I don't want to have to redeploy my application and test. I don't want to have to start over again. And service virtualization technology, especially if you're leveraging an environment-based approach to service virtualization, enables you to actually quickly and dynamically provision individual components. Right? I can actually just click on this loan processor here and select either a live instance or maybe for my test specifically that I'm executing with $1,000 down payment and 150 $150 down payment and $1,000 loan amount, I expect to get a positive response. So I can go ahead and instantiate a virtual version of my loan processor that's going to give me that response. Additionally, I can provision a whole environment, right? So if maybe it's a combination of these components. It's a combination of my backend systems that need to be in a certain state. Then I can go ahead and select, a different environment instance. It's gonna make changes to my environment. And again, I don't have to redeploy the application under test. I don't have to go into a config.xml file or app.config file or into my API gateways and reconfigure all that routing and all that stitching. I can just do that here, and I can do that fairly quickly, just by simply, let's select the positive environment instance. And let's go ahead and provision it. While it's provisioning, obviously you want to be able to do this programmatically, right? So if you're doing this as a part of your pipeline of your CI/CD process, you can just run a curl command here and and stand up this instance uh, quickly. So once my environment's provisioned, I can actually just go back here. We'll go ahead and request that loan again. There it is. There's my response. Looks like the loan provider, I've modified the loan provider name to kind of tell me, hey, this is a virtual asset. By the way, you are interacting with a virtual component within the system, not a real component. But nevertheless, this allows me to do my testing, right? And again, it was a very quick, it was a very simple operation that I executed in order to get this environment up and running. So when we're provisioning complex environments on demand, there's a number of ways to create these environments from scratch, right? That you can create it completely from scratch if you know your payloads, your JSON payloads or your XML payloads. You can always create a virtual service by simply copying pasting that data into your virtual responses. If you have definition files, so Swagger files, WSDL files are obviously a common way of creating virtual services. But probably the most popular way is through record and playback. And the reason why it's so popular is because it gives you a lot up front, right? It not only does it give you the interaction between your application under test and its dependencies, right? Whether it's the order of operations, whether it's the calls that are being made directly to those backend services, but it also gives you a lot of that data up front, right? So which can be a challenge to obtain. So when you record that data, what we're doing is we're defining some monitors, we're defining some proxies that capture request response pairs, or in the case of asynchronous calls, maybe just a specific call, some specific operation. We capture that in the traffic file, and from that traffic file, we can actually deduct a lot of the underlying logic in the virtual service, right? We can look at the traffic file, we can pull out some intelligent correlations and set up your service, set up your virtual service to reflect the real services based on that traffic alone. Once those virtual services are deployed, we just need to reconfigure our application under test to point at those virtual services. And at this point, we can actually reuse those same proxies. We can reuse those same monitors, right? Where we initially used them to record traffic, we can now use them to route traffic. And this is where your integrations with things like Jenkins, GitLab, Azure DevOps, etc., really comes into play, because you do want to be able to do this dynamically. You want to be able to do this as a part of your test automation suite, whether it's a functional test suite or, maybe you're running some UI tests, something like that. Before you do run that complete suite, you want to bring your environment into a certain state, and you can do that programmatically using these proxies and monitors. So provisioning, validating complex environments on demand. A must. Service virtualization can absolutely enable that. And again, you don't have to redeploy your application and a test here. You take control of the environment, and that's so important for test organizations to be able to do that. The next step is to build realistic and dynamic services and control application behaviors. So obviously, the service we just looked at, the loan processor, basically would just give me a yes or a no, right? Not too much complexity, not too much statefulness, not too much in terms of persistent data that needs to be honored there. But when we do look at end-to-end testing and user acceptance testing, those kind of higher level tests, it typically does take an orchestration across multiple services in order to complete those use cases. Now, in service virtualization, there's kind of this 80-20 rule that you might see is that if your environment requirements or your test requirements really don't need don't require anything complex from your services, you may not necessarily need a full-fledged service virtualization solution, right? If all you need is a 200 status response or 200 ping from some arbitrary service, there are very minimal and simple solutions that can do that, including API gateways. I mean, a lot of them actually have this functionality already built in, where they can just kind of give you some some response, right, and some status code. On the other spectrum of that, you have overly complex use cases where you're you really have to deploy the whole environment, right? Where you're when you start using service virtualization there, all of a sudden you're finding you're really rebuilding real service logic. And if you're going to do that, you might as well just stand up the real service. And then you have the 80%, right? So this is kind of where the majority of your service virtualization use cases, where you're validating APIs, you're doing some service level testing, interaction based testing, health checks, basically plugging holes in your environment to make sure that you do have a stable environment, with data and with the necessary services in order to do your test automation. Now this is it makes sense. However, what you kind of want to realize is that a lot of the return on investment actually happens here on this latter 10%. And the reason this happens is because many organizations still struggle with adapting a scalable and an efficient test automation strategy. We obviously have the test pyramid that constitutes that you should be creating tests at different levels of scope. That the lower the scope of your tests, the more quantity of tests you should have, essentially. However, what we see with most organizations is sort of a kind of a top heavy approach, right? And it makes sense, right? A lot of our test requirements, a lot of our features are defined at a user level, so it's much easier to define a manual test or a UI test from a user's perspective than it is to melt those test cases down into lower level tests like API tests, unit tests, etc. But this sort of top heavy approach really contributes to having more complex, more longer end-to-end tests and UI tests. So when we think about service virtualization and we think about stabilizing test environments, these are the types of test scenarios that we have to consider, especially if we want to unlock all that all that ROI for our test teams. So, what makes those use cases difficult? A lot of times it's state changes, and there's different types of state changes that can occur within your system that can be difficult to use service virtualization with. Among those is sequence-based flows. What that means is, you have your application under test. Maybe you have a service. It's polling some other service and looking for a status, right? And it just makes get status calls. And the service is, going to return, well, status pending. And then it's going to make another request and say get status. Now, this call that it's making, it's not different from the previous call in any way. It's still just a get status call. There's nothing unique about it other than it's just another call in a sequence of polling calls to the service. And the service might still be responding, pending, right? So And then it goes get status again. Like, what is the status? And then finally, at some point down the road, the real service will respond with, uh, hey, yeah, approved. So, and that essentially constitutes the user scenario, right? That's the test is to get the status. And the way this real service behaves, it's really difficult to create a virtual representation on that unless you have some sort of sequence based logic that you can build into that service in order to, eventually after a certain amount of requests, to basically change its state. Um, so that's one challenge that we need to tackle for complex virtual services and for enabling complex end-to-end scenarios. Another one is, again, when we have multiple services with which our application or test is interacting, and the full end-to-end scenario is basically a result of that complete interaction. For example, your application or test might be making a call to some user data service. This user data service is going to return a user ID, which then subsequently is reused in another API call to some other account, which is, account data. This account data API call is going to return an account ID, which then is used for some sort of transaction, with another third-party payment processing service. And only we get a response back to our application or test that says, "Hey, this flow was successful," right? And then on the front end in the browser, you'll see, your balance or something like that updated with the new amount. Well, when we're virtualizing, when we're creating a sandbox for this complete end-to-end flow, we have to consider multiple services. We have to consider multiple data sets, and we have to consider state. At the end of the day, the final amount should reflect, uh, whatever these steps actually did, right? If we're depositing $50 into an account, we should see $50 in that account from a testing perspective. That's how we validate that everything took place as expected. So so from that perspective, let's actually take a look at another example here. So let's navigate back to Parabank. And my system here, Parabank, actually does have a backend REST API service. So if I actually pull this up here, there it is. So this is a full REST API. You've probably seen, a Swagger UI where you can do various operations, create accounts, manage customer information, etc. Uh, Perform operations like this loan processor. All right, all of that is taken care of on the back end. Now, when we're creating a virtual representation or a virtual sandbox of this Parabank REST API, we might not necessarily need all of this functionality, right? Like this database management operations. We probably want to kind of abstract that out. We don't necessarily need our our, our tests to interact with kind of some of these administrative resources that they really shouldn't have access to. So when we create a virtual representation or a sandbox of our Parabank application, what we might want to do is we might just want to create a subset of of those resources, and that's what we have here. So we have a sandbox, virtual REST API sandbox that's deployed on at a Docker container somewhere, and we have operations um, like this customer ID, for example. If I go ahead and do a get customer ID call, this is actually going to return some data for us. Let's do it. And then there's my response, right? There's a user in there, John Parasoft, and some additional information here. I'm getting a 200. On the back end here, we actually have a set of data that we can interact with. And I have this sandbox data set. So if I actually drill in here and I take a look at my customers, I should see, there he is, right? John Parasoft with all of that data that we just got directly from our API. Now, when we talk about statefulness, that means that if I make any changes to this user, if I do this update customer operation, whatever updates, first name, last name, whatever changes I make, we should see those changes not only in our responses, but also on that backend data, right? So if I just go ahead and fill this in, we'll change the last name. Let's fill in a social security number. And we'll need some authentication here. Okay, so we went ahead and ran our post operation. Now, if I refresh my data set, there it is, right? So all those changes are persisted. And not only that, not only do I see these changes reflected in my data set, if I go back to my get operation where we're requesting that information from the API and we go ahead and run it again, we'll see all that data has been updated. Now, if I'm running these tests in test automation, or I have some sort of shared environment, and I'm running these, I'm running tests, I'm interacting with my sandbox, or my application or test is interacting with my sandbox. There's probably a certain point which I get to where I want to bring it all to its initial state, right? Maybe I've created too many records. Maybe I've modified the records in a way where I can't can no longer interact with that data. So by creating virtual sandboxes, by leveraging API simulation, we can actually add additional functionality into our API sandboxes. For example, the ability to reset a sandbox. If I go ahead and just say, let's go ahead and reset it to its initial state, it's going to run an operation to do exactly that. And then if I go ahead and refresh my data set, I should actually see this data set reverted to its initial state. And that's kind of what we want to get to, right? We want to be able to dynamically have flexible but also complex enough um, systems and APIs that will enable us to control our test environments. So with that, let's go ahead and recap here. So we're able to provision and validate complex environments. We can build realistic and dynamic services, right? So our rich functionality enables simulation of complex use cases and does unlock that additional 10%, right? That 80-20 rule is now more of a 90-10 rule, because we can do some of those more complicated things that that will typically require a complete backend system. Let's talk about scalability, right? So how do these things get deployed? I mentioned, my virtual service is, sitting in a Docker container um, somewhere. But what happens if I want to stand up a new sandbox, or maybe I have another team that's joining, uh, and I want to enable them, right? I want to give them, I want to provide them with another sandbox. So let's actually do that. Let's give them a name. Let's call them Team Purple, for example, and let's deploy a new instance, or a new sandbox for them. We'll call them, Parabox Purple, and we'll give them their own unique isolated environment. So let's put them on a separate environment and a separate port, and we'll just go ahead and execute this job here. And again, this is something that we can do with just a curl command, right? This can all be done programmatically, or this can be done through REST APIs. This is something that shouldn't be a complex or a complicated step to stand up these environments. And while we do that, let's actually take a look at what's happening behind the scenes. So behind the scenes, we have myself, or a user, tester, or developer who needs access to a test environment. Um, we've already created some copy of this virtual service. We call this the golden copy of virtual service. So either a development team, or a team or a test team, or your COE, they've developed a production grade virtual service that represents your application, or your application dependencies. Additionally, there's a separate data set, right? You can actually see there's sort of this modular approach where the service itself and the data are separated from each other. This is done by design, so that if you have to make changes to your service under test, you don't necessarily have to go in and modify the data. If you have to modify the data, you don't necessarily have to go back and update the schemas, so on and so forth, right? It's for maintainability purposes. But when we do request a new access, or we provision a new API sandbox, we're basically just cloning these assets, right? We're cloning these assets. We can isolate them on a unique port. We can isolate them on a unique path. We can also isolate them on a unique server, which we'll see in a second here. And for any new user that requests access, now I'm onboarding another team, right? And we want to provide an API sandbox for them. We have customer integrations, right? Our customer integrations are asking for a dev portal that they can test their integrations in. So we can go ahead and provision a sandbox for them now as well, and expose that sandbox as a set of APIs or endpoints. And the scalability here is, it can go either way, right? We can either deploy all of these services on, on one instance, on one virtualized server, or if your organization is heavy into Docker or containers or OpenShift, um, all of these environments, all these API sandboxes can be completely on their own unique containers, their own unique instances, pods, clusters, etc. Right? So there's a lot of flexibility here. You can scale out horizontally, you can scale out vertically. Um, that's kind of the goal, right? And you can do that on demand. You can do that quickly. So if we actually go back um, to our operation here, right? We went ahead and ran this job to create a brand new instance for us. What we'll see is if I go back to my my sandbox here and I just changed the port number here, I think we did 9095 or something like that. We'll go ahead and explore. There it is, right? There's my brand new sandbox on a unique port that has its own separate set of data, right? If I go ahead and run that get call again, I should get all that data in its initial state. If I go to my test data module here and take a look at all of my existing data sets, I'll see a brand new sandbox data set called Sandbox, Parabox Purple, right? To serve just for Team Purple over there. So finally, we're able to build complex services. We're able to deploy new services, new infrastructure, new API sandboxes on demand. Um, Everybody loves it. How do I quantify this? How do I quantify the benefits? How do I quantify the usage? Well, first of all, let's take a look at how API sandboxes can be actually used across various enterprises. I think today's focus, we're really kind of focused on quality assurance today, right? Things like environment stability, being able to validate edge cases, removing data constraints. But service virtualization can be leveraged in development as well, right? Sandboxing, prototyping, even for collaboration. Let's say you have a prototype of a service that you've developed as a virtual service. You can share that service with anyone on your team, right? They can work with that. They can do something with that. On the other side of that spectrum is operations. So a very common use case now is for using service virtualization for sales demonstrations and standing up sales environments so that sales teams can demonstrate the value of your product, of your solutions to prospects without having to work inside a production environment. Training, right? If you're onboarding new employees, for example, you're a bank and you're onboarding agents, right? That need to do operations within the banking application. Those employees need data. They need to be able to execute end-to-end flows. And again, you don't want to expose production environment and real production data to to those new employees, to those trainees. And of course, customer integrations. If your organization is exposing APIs or providing APIs or providing solutions and services to partners and customers, um, you don't want to keep them waiting, right? You want them to have a positive experience, and service virtualization can enable you to create those dev portals for your customers as you're onboarding those customers, so that they have something that they can hit the ground running with, right, and have a very positive experience. Generally speaking, you're going to want to have an orchestration platform. You're going to want to be able to see, the health of your system, uh, the virtual services that are being deployed, how are they being utilized, debugging, right? Being able to see traffic going in and out of those virtual services. So all of that is obviously exposed through a platform that can provide that type of insight. And of course, utilization reports, right? Hit counts, hit statistics. If you have somebody who's performance testing against those virtual services, you want to make sure there's an appropriate chargeback model where you're covering the costs of of maintenance and providing those virtual services and that infrastructure. So again, having that insight, having that visibility will enable you to to really get value from service virtualization within your organization. So with that, that kind of brings us to our conclusion, right? So service virtualization again checks the boxes as far as provisioning stable, dynamic test, dev, and ops environments. Uh, whether it's a matter of provisioning those environments without redeploying your application or a test, whether it's uh, covering some of those more complex end-to-end test cases that you may not necessarily always have all the data for that you need, whether it's scalability requirements that you're looking to address. Service virtualization can do that for you, right? So um, real services need the whole environment to work properly. Virtualizing can do that for you. Sandboxes should behave like real services. Rich functionality and breadth of capability within your service virtualization solution will do that for you. Sandboxes should be low cost, right? It should have a clear return on investment in your practice, and it should be scalable, secure, and we've demonstrated how we can do that. With that, we're going to take a look at questions here in a second, but please do feel free to check out any additional resources on parasoft.com. Feel free to download the Service Virtualization Community Edition, which is a nice, free, and quick way to get started with service virtualization, and take a look at our case studies with our customers and how our customers are utilizing service virtualization in their organizations.
Great.
So,
Thank you, Gregory. Great
yeah,
job.
thank you.
Got a few questions here. I'll throw them up on stage and you can take a crack at them.
Absolutely. So we have a question here. Great question. Is it more successful? I'll just go ahead and go from the top here as most upvoted questions. Is it more successful to have the simulators updated by devs as they change code, or for it to be done by test team, which likely means it will not be in sync with the code commit? Great question. So generally speaking, this is kind of a conversation of your organizational structure, and from sort of a governance perspective, what we typically recommend is that teams that develop their virtual services test those and validate those services locally. Now, if you think about the dev team that actually is developing the real service, it does make sense for those dev teams to actually create the virtual service as well, keep it maintained, and that really comes from the domain knowledge of that specific service, right? Obviously, they have that insight; they know how that virtual service should behave. That being said, that's not always the the real thing, right? And so, from a tools perspective, it's really important to understand what capabilities tools offer from a maintenance perspective. So for example, obviously, I'm here with Parasoft. Parasoft, we have something called a change advisor, which means if your dev team doesn't have the cycles or the bandwidth to necessarily go in and do the maintenance of virtual services based on their code commits, chances are they've probably at least updated their Swagger definition file or their WSDL, etc. So just being able to import that and apply all the necessary changes in a sort of intelligent way. If your tool can do that for you, that's already saving you a lot of the cost, and it makes it much easier to shift some of that work, not just to the test team, but actually automate a lot of that, right? So I guess to short answer your question, whether it's the dev team or the test team, that type of maintenance ideally should be automated. If it's not automated, then at that point, it really come down to the tools, and your tools should enable either dev team or the test team to make those updates without necessarily having to do a lot of back and forth between dev and test teams.
All right.
Next question here. Is there an example of a test that gives you the wrong answer? Yeah, absolutely. I mean, we can kind of dive back into our demo application here, actually. So if we go back to this loan processor, and we go back to my environment manager, right, I should be able to just provision an example with the wrong answer again quickly and dynamically. And I can do that, right? So I can go ahead and select an instance that is always going to give me a negative answer. And if I go ahead and provision this environment instance and I go back to my loan processor and I request the same amount here, I should actually get a negative response. There it is, right? So it's actually going to say this loan has been denied. And again, I have a loan provider name that's going to tell me it's declined. But ideally, what you probably want is some sort of a data-driven response, right? You want some sort of logic in your services or in your virtual services that can figure out on their own whether it should be a positive response or a negative response. And that a lot of times does come down to the test data. So if we actually look at the data set that's driving my some of my use cases here, I have a loan processor here, for example. I can actually have a data-driven virtual service that can respond to any loan amount with any available amount, but with the down payment, with some logic around the down payment here. And if I go ahead and instantiate this data-driven um, loan processor instance, and I go back here, and we'll just do that same loan amount, right? We're going to be denied because it's going to want down payment of $500 or more. If I go back and make a loan request, for some crazy amount here, but as long as the down payment amount is over $500, I'm actually going to get approved for a loan. So again, this is kind of when you're starting to unlock that additional ROI, is when your virtual services can do both things based on your test requirements. So depending on what you want to validate and what your tests are doing, your virtual services should be meeting those requirements.
Cool. Thanks, Gregory. I
Talk about the
think I'm definitely
organization.
going to come to Parabank and get my loan.
Yeah.
Last one.
Yeah, just yeah, very secure. um, talking about the organizations having a top-heavy approach that helps hold testers back from automating, but what else do you think holds us back, and what are ways to overcome that? Great question. I think I think hold back, right? It's it's if we take a look at the slide here for a second, actually, let's go back to it. Oh, I guess, yeah. That's so when we're looking at the slide here, right? And we think about API testing. It really kind of falls into this no man's land, where on one hand, you have to be technical enough and you have to have that domain knowledge of the services to actually develop API tests. Not only that, you have to understand how your APIs interact with various other services, and that can be very, very complicated, right? Because there could be tens, if not, hundreds of API calls that are kind of going back and forth, or it may not even be necessarily API calls, right? It might be some other um, difficult, some other complicated protocol that could be doing something else. So melting this ice cream cone really comes down to being able to either record or capture these UI tests and manual tests and give insight into what is actually happening behind the scenes. Now on our side on Parasoft, we address this by enabling testers to record their manual tests in the browser. We capture API traffic. We use AI, machine learning, etc., to deduct from the traffic what is actually happening. Whether there's tokens that are being passed from one API call to another, whether there are specific, status elements that need to be validated on, right? Like a success element or a failure element or a specific ID that needs to be validated on in the response in order for it to be a good automated test. From a unit testing perspective, when you look at dev, when you look at agile development velocity, a lot of times delivery takes priority over quality, right? So there are times where dev teams simply don't have time to write unit tests. So from that perspective, you're looking for solutions that can help you automate the creation of unit tests. Again, on our side, we have our unit test assistant that will essentially generate unit tests for Java code for developers as they're writing new code, or help them with TDD practices, right, where it helps you generate tests before you've actually written any method or any class or anything like that. So from that perspective, it's really about giving enabling teams with tools that expose the underlying functionality of your application, and of course automation, right? So anything that you can do from an automation perspective, whether you're converting your automated UI tests into some API test, look at the test results, see, okay, I'm validating this, but I don't have a lower level test for this. Can I validate this at a lower level? Can this be a health check? Can this be an integration test between two services, or between uh, two two components within the system? Can this be a contract test, right? Can I break this down into a lower level test? A lot of times, those are the kinds of things that you might want to do in order to achieve a more scalable and efficient test automation strategy.
All right. With that, I think we are out of time. Thank you very much, Gregory. If anybody has any other questions, we do encourage you to drop over to the Parasoft booth, check them out. Someone will be there to talk to you about anything else you want to talk about. If there's nothing else, then thank you all and enjoy the last session.
Absolutely. Thank you so much. Have a great day.